Good morning. Good morning, Namaskar. Good morning, everybody. This is Suraj Singh speaking from Bharat, India on this day, March 4, 2022, Friday, 3:42 a.m. नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक चार मार्च 2022 शुक्रवार 3:43 and title of talk as usual is quality and coordination. Let me say first of all, see these files. This is my email ID suraj underscore engineer suraj underscore engineer at yahoo.co.uk. This is my email address. If you wish, you can write to me. You're most welcome about this subject, about this talk. Phone number is also there. Please, I want to receive your numbers. Probably you can send messages on this number if you wish. No problem to me. Or you can send email to me. I'll welcome your questions, your clarifications, your requirements. And this is International Certificate of Professional Engineers, and this is Chartered Engineer Certificate registered as fellow member in Inspire Institution of Engineers India, which is a statutory body or chartered body. This and then it is your fellow certification based on which I am chartered engineer. Fellow means a top profile of corporate member of Institution of Engineers, and here's file that talks of quality and coordination, and here's a file that's detailed coordination talks. These certificates I like to close now. Chartered engineer certificate and also fellow certification I close now. And now we have issues regarding title. I like to explain first what title is. This is quality project works. Quality projects works. I'm talking of quality as well as coordination, and quality and coordination work together because coordination means the procedure to attain quality, and without coordination nothing is going to work. Nothing works without coordination. Coordination should be in letters and spirit, and same way quality should be a part of your nature, part of your character, part of your performance, part of your thinking, part of your life, part of everywhere. Without quality we cannot move anywhere. We cannot do without quality. Nothing can move, and that's called actually it is work quality, it is performance quality, it is defined quality, it is organized quality, it is a quality that must be, of course, within it is a quality. So it's a quality projects works, and coordination engineering, which is process or procedures. Whatever work we perform, we should be having certain links to each other. We cannot say this activity is independent of others. Yes, there can be independent activities, but certain relations got with other activities, maybe in parallel or in sequence, whatever, some on our organization or on schedule or plan, but coordination is a must. Coordination is forgotten by people. People have mistaken now. There used to be coordination, but now coordination is absent. Very few people are able to coordinate because coordination means you have to concentrate. Coordination is continuous concentration, not just a one. Even if you stop somewhere, you have to keep in mind I stopped here, and you have to restart from that point which was stopped or left. So you get point again, whatever system you get in, you have to find that point again and move further. So coordination is a completely continuous process. And communication is a network of that on which coordination moves, and coordination means we have to interlink each and every aspect, and that's called quality achievement, quality performance, or work on quality. And we can say work should be solid oriented and should be long term, work should be durable work, and that's why it's all concrete and civil engineering and field engineering and whatever engineering we talk of. And those engineers who are too good in this regard, who can do something better than all this, and they are called reliable engineers because their works are reliable. The performance of such engineers is reliable. We can say without reliability coefficient of engineers, work cannot be done. And engineers are those who dedicate themselves and devote themselves, and they don't work only for money but for destiny of getting some project delivered or getting some milestone achieved. Use a landmark achieved, you can call it landmark construction, it can be called milestone achievement, or you can call anything that stays permanently for many decades to come. This only world of civil engineering that is involved in constructing, or you can say many more multiple engineering branches are involved, and civil engineering supports all them. You may call it whatever engineering, and that's why we say work counts are involved in that. Without contact, nothing is possible. Contact doesn't mean Contract in your sense, contract means contract in engineering sense, engineering contracts, and of course we can say safety, health and environment, which applies everywhere, though it was not by name before, like before also, but now it's a formal one, and we cannot do anything without safety, health and environment. And also ergonomics is involved, which we'll discuss later on, and designs, construction methods. Design is important as well as construction methods. Construction methods also kind of, you can say, provisional design, or which can be adopted. The option exists there, same way options exist in designs also. And we have to talk of certain problems which can be solved. And that will be called the process of claims and organization of claims and solution. You can say disputes, avoidance or disputes, you can say adjudication. That's why organization is very important. Now I will show you some files here. For example, this is a quality file we are talking about, and the quality file is very important from every point of view. It's not simply that I say or you say, but it's required. Quality everywhere, and quality cannot be compromised. And you can see this file. There's so many supportive items you can see on there. I don't explain every time because it's also very important to know that we can't waste time like this. But quality engineering and coordination engineering are very important. You can say it's a kind of thread. It's a kind of string and thread. Quality engineering, you can say it's something which is very, very indifferent and cannot be forgotten. It's that one. I'm just talking of communication support and appliance. Coordination. It is coordination. This file. You can see this plate. This plate is one school, Vice Preparatory School, which was constructed 1986-87. It's located in Qatar. City of Doha. It's on Amsalal Al Khor Road. It is certain assembly hall, 14 classrooms, lecture hall, physics and chemistry laboratories, lecture hall, workshops, workshop, worship areas, mass substance, etc. And we have here. And the plate is located in Baghdad, Iraq. Darul Thawra Press Complex. This is Darul Thawra Press Complex here. And all this here you can say ಇದರಲ್ಲಿ thawra press complex and there's kasar mutabarat here, conference palace here you see here in this side, not visible in this picture. And this ethylene plant here, this is located in Ruwais industrial city. Ruwais industrial city 300 kilometers from, located 300 kilometers from Abu Dhabi. And this is a shooting range. This is shooting range about 330 meters in Doha, Qatar itself. Part of ethylene plant, seawater cooling basin. Record Center, Masaid, Qatar. So my dear friends, I'm just browsing this file for you, and this plate is referred to LNG plant located at Ras Laffan in Qatar. Means liquefied natural gas. Qatar gas project Ras Laffan, Qatar. LNG plant showing 4 number LNG tanks located in Ras Laffan. Now, these tanks are part of this plant. I'm talking about these 3 tanks and this tank here. Yeah. These 3 tanks were constructed one time and this separately done. Both all are same, no difference in that. Design is same, work is same, is because of contract. Here, Midmac company, where I worked for 1 year in 1995-96. I was there only for 1 year. This company was involved in civil works, all civil works of these 4 tanks. Shioda was or consortium, we call it TBMM. They were responsible for this. Here, I'm saying this plant shows 4 number LNG tanks. And now, what are properties of these tanks? Let us first try to understand. LNG tanks are, you can say, LNG tanks, let me say, here it says, let's see point of 1. These tanks, LNG tanks, are gigantic in size to contain 140,000 cubic meter of capacity each. Tank size is 76.3 meters diameter and 51 meters height. 76 meter diameter and 51 meter height. Excavation for each tank is 1200 cubic meters. Soil improvement carried out using graded granular fill in many meters thickness in layers, duly compacted and FTD ensured. 1200 board piles, 405 each tank included. 12 board piles cast in place or cast in situ. Foundation constructed of RCC element, 800 thick base. RCC M60, grade M60 with microsilicon was included, 18,000 cubic meter for each tank. Record of surveys we usually call ROS were conducted regularly at every stage weekly until whole tank structure constructed and filled. Tank diameter is 65 meter. Wall thickness is 800 Height of tank 45 meter or more. Exactly, it's more than that. Just I have indicatively written it. It's 50 meter. 50. I correct this one. Real tank is internal containment of cryogenic steel body. 9% nickel cryogenic steel. Air pressure lifted to cupola level, 51 meter above floor. The storage temperature of LNG minus 160 degrees Celsius according to information available. It varies between minus 80 and minus 60. Top is domed, which is cupola, called cupola, with cantilever rack columns. Above 40 meter height of 50 meter height, cantilever size. Cantilever projection on top is 27 meters by 22 meters. It's shown in the sketch. I'll show you that one. A structural concrete tank is RCC, within which PSC post tensioned included cast board in stages 5 meter each vertically using climbing formwork, quick formwork. Each stage cast quantifies to 550 cubic meter. Carbon steel vapor barrier at floor, carbon steel vapor barrier at floor, epoxy coating application on external surfaces. Scope of work consists of civil works of 4 LNG cryogenic concrete tanks, each of 85 cubic capacity, though it is 140,000, but let us say capacity now issue 67-meter diameter and a height of 45 meter. Tanks are founded on engineered structure fill, replacing existing soil up to sound rock below water table. Construction comprised 0.5 meter thick raft foundation, slab with 8.8 mm thick concrete walls poured with climbing shutters. For post-tension walls and base slab, 60 Newton strength microsilica concrete was batched on site. Each roof was built with an air-raised steel cupola and a concrete cover. An in situ concrete cantilever structure 27 and 20 meter was built on each roof to receive mechanical installations. Mid-max scope also included general earthworks, concrete spill channels, basins, and roadworks. Work was executed to very stringent QA, QC, and safety controls. Midmac had total responsibility for civil works in consortium. Principal quantities: excavation 40,000 meter cube or 3 tanks it is, reinforced concrete 43,000 meter cube, and here is plate 9. You can see here, this is, you can see tank itself. The tank here, you can see mechanical handling of this. It's complete tank. This is stays and it's this stair here. You can see that one. It was arrangement at that time. You can see, and this is finished product. You can see how it works. Here it was during, here you can see during construction stage, this one and that one, and this is finished product. And you can see these tanks 1, tanks 2, tanks 3, tanks 4, and this is a plant. You can see, and you may see this internal work being carried out. That's flooring work, or you can see nickel cryogenic tank construction. It's inside tank be done. You can see spacious area for this tank. You may see also surface here, concrete surface in various jumps 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see how much? I guess approximately 5 meters. So if you see these lines, layers, you can see again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means about 50 meters here, and then cupola starts. And this is, you can see ring beam here, you can see very well. And this is form of other one, last time top slab. And this is, you can say here, other one same way, and this is not visible otherwise. And these are all works going on, property works, materials lying here and there. And this is that tank. Also you can say, we'll come back to this and see what to do about. I'm now going to state something on the issue of let me see, what is that? Yes, constructability. 3 number tanks, constructability 3 number tanks. Let's see what is that. And also constructable LNG tanks. Let us see first of all what it says. Constructable 3 number tanks on mid-mark. It says something. Let's see what's that. Let me open this file and see how does this work. It's coming up constructability. Very, I think 3 pages only, not more. It's not big one. Just a reference from mid-mark file itself. Mid-mark file from Facebook, and this is projects. You can say selection of what we have done so far. Mid-mark says mid-mark contracting, and it says location Ras Laffan, Qatar, category industrial, client Ras Laffan liquefied natural gas company, and this is consultant Mitsubishi Heavy Industries, and commencement 1996-1998. And this is the scope of work consisted of civil works of 3 number LNG cryogenic concrete tanks. This is details given here, and you can see same. I used that one. This is your same photo as is here. I'm just referring to you to What is that? So this is not advertisement, just reference I'm giving. I'll close this file now. No need of this file. I'll take another file here, and that is stability LNG tanks again. And see how this says. I'll open another file, and this is thing you can say. This is LNG tank formwork, a new system. It says a new system of formwork. A new system of formwork was developed for construction of LNG tanks. It uses a high strength and rigid steel formwork shell for especially high dimensional accuracy. Special advantage of Bitsuku LNG tank formwork. There's a quick assembly and construction time, no recesses or gaps, simple insertion of heavy anchor plates using guide system, homogeneous smooth concrete surface, optimal use of crane capacity, economical formwork system, high dimensional accuracy. And you can say here, it's just for information, nothing else. This is the artwork which I showed to you. The surface, you can see this again, lines are seen, no issue. This will be covered, and this is mono box betoma. This is betomat, and it's all this. And you can say product is signed like this. This is here, we talked off, we did these three, and therefore you can say access area like this, drain. Just for information, this is, and I like to close this now. I open another file, which is also very important in this case, and that is, I can say, I may be available on the pop-up. If not, I don't know. Construction buildability, design build and general requirement, construction and overall. Let me see this construction buildability. What is that? Let us see. Is a construction exercise that assesses designs from perspective of those that would manufacture. Says actually it is different, what it says. Let me blow up further so that we clear. Let us understand buildability, so understand all these aspects. And buildability is a pre-construction exercise that assesses designs from perspective of those that will manufacture, install components, and carry out construction works. Should not be confused with value engineering. Value engineering, which is used to solve problems and identify and eliminate unwanted costs. So some processes are common to both activities. In very broad terms, you can say buildability should assess elements of designs in relation to achieving desired final quality, meeting program requirements, de-risking perceived problems, and achieving optimum value for money. This is what objective you think so. Buildability should assess. What is that? Quality is important, means it helps in achieving desired final quality. Well, now I say it's not desired, it's mandated, it should be mandated. So we can say achieve desired final quality, meeting program requirements, de-risking perceived problems, and achieving optimum value for money. This is what it is, and it should be. So we can say buildability involves careful. So here are 4 points. One is quality, one is program schedule, program requirement, other is reducing risk on problems, and achieving value of money. So in buildability, advice is given as quality relevance, schedule relevance, risk reduction relevance, and value for money. So it depends. You can yourself understand. Buildability involves careful study and concentration. And consideration, buildability involves careful study and consideration. Now, careful study of what? Sequence of activities that take place on and off site. Sequence of activities that take place on and off site, taking into account state of building and its weatherproof environment, at whatever time. Dimensional criteria setting out and space allowances. Use of plant and equipment to save workers and time and prevent possible damage, practicality, flexibility, and tolerances. Standardization of components and processes, reduction in complexity to shorten learning curve. Identification of appropriate suppliers, prefabrication opportunities, packaging works and allocation of scope in relation to trade and specialist contracts, ease and order of each of other and interface connections and abutments, installation, maintenance, access arrangements, including long-term replacement, health and safety, temporary works such as propping, facade, retention, retaining facilities, and trench support, crane support, formwork, false work, and scaffolding, including gantries. Susceptibility to damage and protective procedures in transit and in situ. Weight and lifting requirements, unloading operations, spare parts, and storage and waste management. And these are certain points. I'll come back. Advances in computer-aided design, that's CAD, and computer-aided manufacturing, that's CAM, as well as introduction of building information modeling are immensely helpful in visualizing many aspects of buildability. However, availability of technology doesn't remove need for engaging practitioners who have hard-won experience and awareness of on-site practicalities and potential pitfalls. Contractors often best placed to advise on issue of buildability. Contractors is often best placed to advise on issue of buildability, and some procurement methods such as construction, organization management contracting, and design and build allow early appointment of contractor to offer advice and feedback on design proposals as they develop. Related articles on design may be, though I'm not referring to them just for information, I'm telling what's the CDM planning period, construction management, customer, all this you can go through this. I'll go back now to talk of this point as we discussed. This very important point in list. As we talked of, this is a sequence of activities that take place, and that is what we have to understand. Take into account how the dimensional criteria, that's very important. Dimensions should fit in the dimensions on all drawings. So dimensional criteria in all drawings very important to computerize it, but to be clear that doesn't impact on works. Setting out criteria and space allowances we have to consider everywhere while during design as well as during execution, and how to use plant and equipment to save our time of workers and save our time as well, and to speed up job, accelerate and prevent possible damages. So we have to plant and equipment are very important considerations as far as time allowance is concerned. We have to organize time, and time is very important. Time speeds up, or time can be lost also if we remain careless. And we have to see practical viewpoint. We have to understand flexibility requirement, tolerances. But to keep in mind practical aspect, it should not be bookish all time. Is practical something. We have to understand this is a part of job, and flexibility which doesn't affect quality, it doesn't affect standards. We have to keep in consideration all that. And then here's how to standardize components and processes. Means if you can typical them, if you can make them typical, if you can them standards, or means it's not the issue international, national standards during good working practice. You can say standardizing components and processes. And reduction in complexity to shorten learning curves means we can learn something very fast. If you understand the concept of that, we consume that, and we know in summary form how to do that. Therefore, complexity should be avoided, complexity should be reduced, and work should be made easy to do. That's very important. Fine, easy to do, but should be correct one, quiet one, and we can say it's better to identify suppliers all time. Must have certain catalog or list that we have. We can refer to these people, these people who are experts in field economically as well as technically, who can give quality product. And we should have opportunities for prefabrication if you have good designs, and we can say work packages and scope we have to define in whatever concern, and we can say placing an order of interference connections, abutments, or whatever we can say installation. So all these points for temporary work, otherwise we can say damage susceptible protective procedures, and all devices are the weight and lifting requirements, uploading. Yeah, all these parts are very common. We have to think of these from time and again. And I close this file as well. I'll open another file. It's much more important than it's I think construction. This I got business. Yeah, LNG tank, 3 numbers, and it is hold on. Uh, Constructability. I don't know what file is coming in. Let us say constructability again, and this comes at okay. Let me see what this says. Science direct, I think, design for constructability, LNG project management. Let us see what is that actually. This is not my point. Let me go to other file. I'm just trying to search that. I think I just missed that point. Where is that? I just saw that file. Constructability and overview, LNG project. No, I own your building management. Just a minute, sorry. Here I do again. General records. It's my folder. It's now, you can say, management. Hold on, please. Just trying to file that. I'll file it soon, no problem. It must be somewhere here. I'll reach that quickly, don't worry. It is constructability, it is here. Constructivity and overview, constructivity building, LNG tank, SAP. Yeah, I got it. VSL news, no, it's not news. Let us see. LNG tank form work. LNG tank form work. Well, I think I've taken that. LNG tank form work. No, this is not that. Construction technique. Buildable construction. That's the problem if I'm not ready in advance. 3 number of times we've already done. And vulnerability, constructability. My God, what happened? I saw that file just now. I lost it. Let us say VL's news. That's a SAP interview. Let's take this point. Okay, let's see what if it does the same thing. See if I got something. Issue of 2000 is old one. Just giving reference to this one. Here is new generation challenges LNG tanks farm system Mosses Mafia Stadium. It's that one. Just for reference, I'm trying to show you. You can see that one here. You can see that one here. And it is sustainable even nuclear 8 is given here. Sustainable development, facts and trends, cover story, and all this such a news. Tank form box it is, and bridges likewise. You can say tank form of this is when tank you how to do construct this. It's a kind of a system. Means you can see supports here, and it's a kind of support, and you can see this tank form of 27 is a bridge here. I'm concerned nuclear 8, so nuclear this is as a tank form work. And let's move further to see. And you see there's a curve here, and stadium here it is. You can see how this works. Stadium just as a part of the assessing sustainability. That's point here. Sustainable development. Initial efforts have been focused on raising awareness of sustainability issues through education, training, and encouraging changes in behavior through green initiatives. Even small individual improvements become major gains. How to measure these efforts? Sustainability covers. Just plow it up, please. Sustainability covers. Let me plow it, please, faster. we have I'm saying we as analysts is talking about clear concept of what sustainability means and does not treat it as a set of easy to manage tasks. Attitudes, initiatives focuses on ST actions, sustainable development actions across 7 different themes. And what is foster a trusting relationship with our clients based on consideration, transparency, and innovation. Incorporate risk management into day-to-day running of company. Lead our business sector in terms of occupational health and safety. Develop our employees' skills and promote equal opportunity. Establish balanced long-term relationship with our partners, suppliers, subcontractors, and ensure that our business respect environment design of works, participate in economic and social life of regions. So, however, well, these are just handle as qualitative approach. First one is self-assessment carried out annually by each one country, usually by administration, finance and advocacy department, each of 42 actions measured against a performance criteria to assess current situation and set an improvement objective for coming year. These assessments are then reviewed by regional management. Okay, this is a procedure of the company, leave it behind. I'm not interested. I'm just trying to find quantitative approach. Okay, both are there, quantitative and qualitative. Worldwide first, I am trying to find usable information. This is not my worldwide first electrical isolation of poster. I think we have to move further. No need of this. Drilling works are going on here, and you may see that this is here, first corrosion resistant addition. BSL was recently awarded as first corrosion protection contract in Hong Kong, Korean Highway approval in Florida. This is their advertisement. I think it's no use for us. Well, I got many in this information. Uh, I think I'm wasting time, is it? Transport. Well, it is just, I think, only informative work. I'm not going, something is good here. You can see that Bavi site insights. This is air. You can see mountains. Airlifted drilling rigs. Airlifted drilling rigs, Hong Kong. Drilling rigs. You can see this. Hangars for drones. Yeah, it is that fact. I was trying for this. It was important for me. This is one system, one cycle. New LNG tank formwork system. That's what I was looking for. Extensive worldwide, you can say involvement, extensive worldwide involvement in construction of LNG tanks has enabled VSL to analyze data and obtain feedback from site production teams to identify typical and specific problems associated with tank construction. Subsequently, developing innovative and unique solutions. Optimized LNG tank formwork system is one such example of this development, and I can now little blow this up for further clarity. Nowadays, storage of liquefied gas is provided by two elements: primary or inner containment of tank, which is typically constructed of steel with a high nickel content, aluminum aluminum, stainless steel, or in some cases post-tension concrete to meet extreme demands of cryogenic conditions. So what is that? Primary or inner containment of tank is typically constructed of steel with a high nickel content, aluminum, stainless steel, or in some cases post-tension concrete to meet extreme demands of cryogenic conditions. Containment must independently be able to withstand hydrostatic load of liquid. Secondary is, this is primary one. Secondary is outer containment, which is most commonly constructed from post-tension concrete, designed to withstand abnormal loads of external origin as well as retaining liquefied gas and vapors should there be a fracture of primary containment. So this is, you can say, comprehensive modular system has developed a known modular system. This secondary containment, it can be used to build entire circular containment structures without need for time consuming and costly modifications to climb form system after installation on site. Formwork system is a comprehensive solution providing suitable solutions for construction of all components of typical here. I'll show you what it wants to say first. Optimize layout of fast track construction. Let me see what it's saying. Including taper walls. Let me finish it first. I want to do this. Including where's including, sorry gentlemen, there's some missing in this, I think. I don't know. I missed that point, right? Largest span. No, I think 160. Yeah, it is that. It is that actually. It's too blown, so I could not see that. So let us move first. What it says, containment. It says including. What is that after that? Including tapered walls. So it is next page actually. Including tapered walls with reducing thicknesses, walls of constant thickness and ring beams. Tapered wall with reducing thicknesses, walls of constant thickness and ring beams. Safety standards and national codes have been taken into account with standardized fixed access ladders for increased safety on climb form. System is highly efficient with fast and safe stripping and closing as well as easy and quick assembly of integrated ring beam support. System development has been based on clearly defined criteria. Firstly, it was important that concrete tank construction could be completed without requirement for any major modification once system was assembled and commissioned. It applies to all aspects including lower tapered tank walls, typical wall sections, ring post-tensioning and installation of mechanical embedded plates and inserts. Clear unobstructed access to all work areas had to be provided, and for all development safety features are vital, including permanent fixed access to top working and training platform, easy stripping, ergonomic components, and an integrated ring beam lowering device. Tank construction be optimized. While designing this new formwork system for tank construction has focused on 5 points. Enhanced safety. System meets international standards and features safe working areas on climb work, including a fully integrated stair ladder, handrails and toe boards. Climbing cones with back anchors are designed with consideration of hollow tendon ducts. What I'm talking about is climbing formwork, that is less time on adjustment of formwork panels, optimize the interfaces between watertight form form ties, watertight form ties, climbing cones, tendon, tendon, ducts and vapors. Barrier plates work cycle has been shortened by minimizing time consuming adjustment of formwork panels. So it says less time on adjustments of formwork panels, optimize interfaces between watertight form ties, climbing cones, tendon ducts and vapor barriers. So interfaces between watertight, so all that is improvement of operational efficiency, system guarantees an optimized working schedule that brings accurate planning and avoids delays. Fast cone anchor assembly improves formwork systems operational efficiency. Furthermore, there is no requirement for additional components to take account of unexpected clashing of post-tensioning and form ties. Surface finishes improve due to reduction in number of form tie relocation holes in form face. Single system for standard section and ring beam. LNG tank formwork system allows casting of both standard sections and ring beam using same form with simple adjustment and only minor additional elements. Modular components for more flexibility. Majority of components for LNG tank formwork system are modular and there is no requirement for advanced training to operate them safely and efficiently. Tapered starter walls, vertical shell walls, buttresses. Beam can all be built without modification of standard components. Adaptability for variable lift heights and wall thicknesses make system suitable for all LNG tanks worldwide. System may also be used on other structures, including piers, columns, buildings, and annular circular containment structures. And then we have customer involved testing. Client system. You can see this is here, it's not clearly written, I can't read that. But well, this is very clear, everybody can understand here. This is complete profile, and here you can say system, and this is access from one area land to one level to another level, and this is completely working here and all that you can see. So this is all forward. Fast track, and this is report construction says highway etc. I'm not going to talk of this though. What is this? It says fast track road construction with PPCP, and what highway owners and users demand quick and low cost infrastructure construction with minimal impact on environment and low long term maintenance. Precast pre-stressed concrete pavement can provide ideal solution with pleasing aesthetics. So this is different subject, we'll discuss it later on. Now I am just inclined on something. We shall let us see what else is there. LNG tank I have covered. This is tied down, so we'll look at that separately. And this is our section. Stadium, I think this is, and stadium support. Later on we'll look into that. So I think I've gone. I'll put this back on, and let's see what's constructibility here. We mean we are talking ultimately constructibility and coordination. So it is limit spans is 18 pages, but what it says, let us see what it says. Because I don't want to confuse, so high voltage and all that will take later on also. It's not correctly, now it's not my subject today. So let's close this and we'll see. coordination goes back, and we talk of that one now. Let me close this also, and let us see how do we move on to this point. Constructibility, building. Constructibility. What is constructibility? Vessels on overview we have seen, energy tanks and all that. Okay. Now we have to stick to point and come back to our position, and that's it. Where let's see where it is now. We have here I was just referring to about some formwork issue. Here we have to see what we have talked of. Now, as we said in writing about this, this is, you can say, early construction stage and how work is going on. You can see, and this is internal area that we did. It was well lit and ventilated. Forced ventilation was allowed because you can see all sides are closed. It's circular tank, closed from roof, and of course there was one access panel, temporary one, through which you could enter. This was forced ventilation all time, so it worked. And you can say it's quite big in scope, and you can see how it works, and you can say, so this was working here, and this is all following work going on, and which is cryogenic steel plate. This was really, you can say, as we said in activities here, we can explain again what it say. Maybe some data confusion problem. Let's say it says LNG tank of this size. You can imagine. Of course, many of you might have seen this tank, but even then we had to discuss about this tank in its letter and spirit so that we can understand what to talk about. It's important quality issue, and I'm saying gigantic size, but means it's quite good. The volume is 140,000 cubic meter, which is good one, and this is 76 meter diameter, or you can say around 75 or 80 meter diameters, and height is say 50 meters. So excavation depends on foundation depth and all that. So you can say in each tank 1200 cubic meter. It's not very big also. If you see this like mass excavation, but problem was that it was rock area. Doha Qatar is generally rock area. It's not sand or clay. It's different, but excavation takes a lot of time there. So excavation generally you find in Qatar itself, excavations done by rock breakers, or you can say excavator where excavation bucket is replaced by hammer, and usually it's called rock breaker, or you can call it you can call it a hammer. Sometimes we call it in place of jackhammer. Excavator hammer is used, and it's not like that mass excavation in one go. Excavation is not permissible. So excavation of course takes time, and it takes time, considerable time, and 1200 cubic meter by excavation of one tank by jackhammer by rock breaker is a considerable job. It takes time, and of course soil improvement was required there, though maybe some area in that tank near sea it is, and the soil improvement is required because of many reasons. Maybe weak soil or weak rock, you can say. Actually it was for safety, you can say, like that, using graded granular fill. Well, I support all time this graded granular fill because long-term effects are better in this case. Soil improvement affected by granular fill, or we can call it engineered fill, in whatever thickness in layers, and we can achieve after having compacted fill. Excellent FDD, field dry density, can be achieved. An issue of consolidation is it's not that important in this case if it's not clay fill. And of course there are two ways. One is below this RCC circular tank. One is this, you can say, piling, and in other areas you may say different type of. So what combination of piles and raft, a kind of foundation it is. In one tank 1200 mm board piles 405 for each tank, 405 each tank. So 1200 mm die, about 4 feet. 4 feet not very small also, not very big as well. So these 405 each tank were done. Foundation constructed of 800 thick base, and M60 concrete was used, where microsilica integrated, and microsilica means maximum is 9%, not more than that, but actually I don't remember what percentage was in this case, because it was not narrow fill or thin concrete, it's big mass concrete, so you can say there is no problem once microsilica, a supplementary cementing material, is used that works in place of SRC as well as it works in place of corrosion resistant concrete. Because microsilica, many of you know, I think generally you know what is meaning of microsilica and how does it work. Microsilica, we call it in other ways microsilica or silica fumes, you say. Silica fume, which is smoke of silica, and particle size of this silica fume is very small. It's not very big, you can say it's very small size. If you smoke, you see there is smoke. If you smoke, you find particle size of smoke, and you can say microsilica particle is smaller than that. So function of this particle is that microsilica coats each particle, or many particle coats cement particles. So a kind of deburning is done on these particles. You try to get my point. When microsilica or silica fume particles flow off, these stick themselves, adhere themselves to cement particles, and though it's not visible because it's very minute structure, each and every particle of cement is coated temporarily by silica fumes. And once concrete is mixed, it is laid or placed, it cannot dry, it cannot harden, cannot set, cannot start, reaction cannot start until it's vibrated well. So microsilica mixed concrete, at mixed concrete grade M60 was used in this tank of 18,000 cubic meters each concrete requirement. And it's very important point, use this concrete. In those days when people didn't know much about that, now microsilica is very common. So everybody knows about this, and there are GGBS also these days, granulated glass granulated, blast furnace slag, and of course the lower profile is PFA, pulverized fuel ash. There are different materials, and we can say there are many more materials in list, but generally PFA, then GGBS, and the microsilica sequence we see from bottom. First requirement could be PFA, but there is a limitation on that. PFA cannot be used in all respects to satisfy all requirements. Then we can say higher profile is GGBS, granulated blast furnace slag, which is more reliable than PFA, and then microsilica, which is a limit. So you can supplementary cementing materials are used. We call them supplementary cementing materials. These are very, very common these days for crack prevention, crack formation prevention, for corrosion, or for resisting rapid chloride penetration into concrete. And likewise, you can say these requirements, this production, this availability of SCMs or supplementary cementing materials have actually declared, practically speaking, your sulfate resisting concrete obsolete, and OPC also 90 or 30% obsolete, because we don't use OPC nowadays to that limit. Up to 70%, or in some cases up to 25%, can be replaced by supplementary cementing materials like GGBS. And if you use PFA, maximum limit is 25% that can be replaced, and GGBS is more powerful, and microsilica has no limit. For all high strength concretes productions in pre-stressing work, otherwise microsilica is this and mixed. Now that is tank diameter 65 There are more, I'm not interested in diameters, just for reference only I'm showing it. Thickness is 800 mm wall thickness and height of tank is 1. Now record of surveys were conducted regularly at every stage, frequently during week until whole structure construction failed. What's the purpose of that? We have to understand. But to understand purpose of level records. See this heavy structure, we can say 800 mm thick walls and 75 to 80 meters in diameter. And of course there's raft below. Pile is not an issue because pile is already within soil. Question is, means there are every chance it's a mass concrete. You can say mass concrete, massive block, or you can also say whole tank is a massive block. Whole tank is a massive block, and there's no question of construction joint in that. So it's one unit. There are always a concern of cracking, concern of thermal effects, a concern of all that. So specified and special technique must be used for this. We can say then internal and external. There are two tanks in this. External tank is for protection. If there's some problem within internal tank, there's some safety problem. It can burst some brakes. What happens? It's duty of this RCC or PSC tank, walls, base, and roof, which is cupola, to work safely in all respects. Whatever contents of gas, liquefied gas, we surge or leaked, this tank will take care of this. This tank should be watertight or hydraulically tight, and that's an important point. So there are two tanks in one. One is a functional or practical tank, that's metallic one inside, cryogenic steel tank with 9% nickel composition, and this is actual tank, whereas a standby tank, you may say. Of course it's not standby, it's permanent. That's RCC chamber, this cylinder with cupola roof, and this is very important point. The real tank is the internal containment of cryogenic steel body, and 9% nickel cryogenic steel air pressure lifted to cupola at whatever level, 51 meters, storing temperature minus 80 to minus 60 degrees Celsius, and dome at top called cupola. And we can say, of course, there's a provision of, you can say, platform at this level, and that is 27 into 22 meters. Platform is also quite big. Structural concrete, and we have to see our post tensioning effect of tendons, cables. Each stage quantities they are, and carbon steel vapor barrier at floor and epoxy coating externally. Therefore, we can say scope of work consists of civil works of 4 LNG cryogenic concrete tanks, each 85,000 meter cube capacity. Tanks are founded on engineered structure fill, replacing existing soil. So it's all, that I'm not interested in that. About this work, how it is done, and that was a file I read yesterday. I don't know, I could miss that somewhere. Construction VSL news now. Construction over general records, management documents, chapters. Overview. Let us see what it says. Overview. This says something important. I'll check. I close that one. I'm trying to find a file. There's so many files. I forgot the name of that. Let me see. Which file is this? I no, it's not that. They are mistaken. I missed that one somewhere. No, this is BIM related. Leave it here. This is some BIM. I'm interested in BIM. I'm interested in so many files. VSL news, buildability. Let me see. There is a chapters, buildability, construction, energy tanks. If I end up book covers, board. 3 numbers. No, it's not now. LNG tanks. Let me see what's that. Sometimes it's misconception. So many files I open and forget them. No, it's not that. Let me go back to my folder and see where it's gone. I did a lot of work yesterday, forgot where it is. So many files and folders. Let me see if I can find from here. Please excuse me. It's technical work and you forget quickly. Management work, documents, other statements, chapters, other statements. I'll see where some constructivity, coordination, practical, SAP, PLC news of construction techniques, and development construction techniques. That, in fact, development of construction technique. Maybe it is that one. I think it's that one. Okay. I got it. So I'm opening that now. It is, you can say, development of construction technique of LNG storage tanks wall using precast concrete panels. Yesterday we discussed something in this, but I could miss that now. Come back to that point, and it's important point, in fact, very important point. And let's say what's this? It's article. What's the name of this? Open access. Okay. Reference you can see here is given. This is we're talking of something replacing the conventional one. So what it says, development of construction technique of LNG storage tank wall using precast concrete panels. We referred yesterday. Again, I'm showing to you because this is by SCGO, and so many others. You can see all these. Department of Civil Engineering, Civil and Environmental Engineering, College of Engineering. This is somewhere in Korea. And what's abstract? I'll read again. Constructed with cast in place CIP concrete method. However, this method is difficult for construction because it is significantly affected by condition of construction site, such as climate and material supply conditions. This construction method consumes construction time and cost. Recently, to reduce construction time costs, various construction methods, such as jump form, as we say, slip form method, are being applied to LNG storage tank walls. This limit the construction of inner tank has to be conducted. Construction of inner tank has to be conducted after construction of outer tank wall is over. Meanwhile, precast concrete method has some different characteristics compared with the CIP method. In PC method, structural members are previously manufactured at a factory and transported to construction site to be assembled. There are advantages, you can say. Advantages which are reduction of construction time and cost, of course, an improvement on quality control and durability. Main objectives of this paper are to introduce a new construction technique for LNG storage tank wall using precast panels, to overcome existing limitations and discuss benefits of technology. In addition, to verify applicability of now 190, I'll make it 190 so that we can clearly see. Still it's not coming in there. Let's put up 180, and so let us see it comes full. Now introduction is, as demand for LNG, which accounts for a large share of world's energy consumption, increases, construction demand for LNG storage tank is also increases, you can say. Accordingly, a number of researchers on construction method have been developed to reduce cost and period of construction of LNG storage tanks. LNG storage tanks are containment structures, as we have discussed already and seen. Practice also on site. LNG storage tanks are containment structure to liquefy and store natural gas below minus 160 degrees Celsius. It's not necessary, but let us say up to minus 160 degrees Celsius with single containment tank and double containment tanks. Single containment tanks and double containment tanks had been used in the past. In recent years, full containment tanks have been mainly used. Full containment tanks basically consist of inner tank and outer tank. Full containment tanks basically consist of an inner tank and an outer tank. Inner tank is made of 9% nickel steel plate with physical properties for cryogenic to safely store LNG and prevent gas and liquid leakage. What purpose is? The purpose of steel for cryogenic, nickel steel plate with physical properties of cryogenic to safely store LNG and prevent gas and liquid leakage. Outer tank is constructed by applying cast in place method using concrete with formability of material to ensure safety of LNG storage tank system. Outer tank is constructed by applying cast in place method using concrete with formability of material to ensure safety of LNG storage tank systems. However, it's difficult to control construction because CIP method, cast in place method, is affected by construction site conditions such as weather conditions and material supply conditions. Since all absolutely necessary to install and dismantle temporary form, construction time and cost may increase when applied to LNG storage tanks. An inner tank must be constructed after construction of outer tank and roof completes. Therefore, in this writing of paper, a new construction method to rapidly construct LNG storage tanks is proposed by applying a precast method that satisfies economy and construction simultaneously to outer tank with considering problems of construction and improvement of existing LNG storage tanks. This method has advantage of replacing temporary foam used in existing LNG storage tanks with PC panels to reduce time to dismantle foam and to simultaneously construct inner tank and outer tank. In order to verify construction method proposed in this writing, a part of real scale LNG storage tanks was stalled for a Markov test and strain sensors used to monitor behavior of Markov during construction in real time. Constructability and structural safety valuations were discussed. Components of LNG storage tanks. LNG storage tank is a cylindrical containment for storage. Cylindrical containment of storage for storage of liquefied natural gas below minus 160 degrees Celsius and reducing volume to 1 over 600. Reducing volume to 1 over 600 means 600, when you say it's gaseous form, it's 600 times more or 600 times than its liquid form. LNG storage tanks consist of an inner tank and an outer tank. Inner tank and outer tank. You can say LNG storage tanks consists of an inner tank and an outer tank. Inner tank is made of 9% nickel steel to safely store cryogenic LNG and prevent leakage. Outer tank is composed of reinforced concrete and pre-stressed concrete to safely protect inside of storage tank and disconnect from ambient temperature. In order to prevent direct contact with outer tank and leakage to outside, when an accident occurs in which an inner tank is defective and leaks, leakage of LNG occurs. A wall liner made of a thin steel plate, serving as a vapor barrier on inner surface of outer tank. A wall liner made of a thin steel plate serving as a vapor barrier on inner surface of outer tank should be installed. Construction of wall liner is carried out inside outer tank after completion of outer tank. In most LNG storage tanks, construction using cast in place method. Construction of inner tank can be done. This is overall shape and cross section of LNG storage tank. Let me put on my battery. Now you can see section here as well as tank both. It's a real tank and this is real section. Both are there. What we see, if you can see here, this is tank wall and this is below structure. You can see raft, fans or whatever. And here is cupola. And here's ring beam. You can see all that here. Now this wall here is this one. You may see here. This portion below is this one. Bottom slab, you may say bottom slab for gas. And here is ring beam, which is this one. And you can see roof here, and that's this, of course. So this is your tank. This is tank external structure. This is all external structure. This roof, not very thick, but it's liner here, blue line you can see. And ring beam here. This is now inner tank. This is a line only. This is inner tank, you can see. Inner tank, it goes on reducing in section. Here it is base, and you can see here. This is inner tank, steel tank, and this is roof of this. You can see. Inner tank, you can see this, I think saffron color here or something like that. Inner tank, and this is here insulation. This is insulation here. Maintain temperature, current, and wall liners. This is RCC tank wall liner, external tank liner, outer tank it is, and in this area, in this in this volume. LNG minus 163 degrees Celsius, minus 163 degrees Celsius is shown. Here is insulation material, and that's what this tank shows. Now this figure, LNG storage tank components. Now we have to go up and see what does it mean, what does it state. States application of precast concrete panels, that's we are going to discuss. What's that all about? That's important one, and it's in one way or other way. We have to understand what does it say. In this talk, in this chapter, construction cases of precast panels are discussed. Construction method proposed in this paper is compared with existing construction method of LNG storage tanks. Construction cost cases. Now, as structure of building is high rise, high rise we are talking. This high rise, of course, it's also like high rise, 50 meters. As the structure of building is becoming high rise or become already high rise, enlargement and diversification in whole world. Existing cast in place method has limitations, certain limitations, not only shortening of construction time, but also ensuring quality of concrete. Precast method is a way to modularize structure by manufacturing large amounts of members such as column, walls, beams and floors at factory. Then member transported to site and assembled using applying PC method are shown here. It's generally you all know that. You can see the sketch shows precast concrete, and of course CIP is also shown. Something is CIP and something is precast. Something is CIP is cast in place and something is precast. This is just for showing and storing. Now we can say figure is shown. PC panels applied in each case have advantage of being able to be used as permanent form by replacing temporary form. Also continuity of this permanent form, that is PC. This panel applied in each case have advantage of being able to be used as permanent form by replacing temporary form. Also continuity of reinforcement or reinforced bar can be ensured. Construction case of bridge piers using PC panels. That is A, you can see first one from left, inner PC installation. Inner PC installation. Then B is reinforcement. And C is outer PC installation. Then D is joint ceiling. And of course, construction of bridge pier. method. Existing construction method of LNG storage tanks has process of constructing outer tank after construction of foundation and bottom slab. Construction of foundation and bottom slab. After construction of which you can start LNG storage tanks. Climbing form using temporary form into site. During construction of outer tank, roof tank is built at same time. Outer tank is constructed by applying climbing form using temporary form into site. Here's what you say. I kept silent for a few seconds. Here's outer tank is constructed by applying climbing form using temporary form into site. During construction of outer tank, roof of tank is built at same time. Roof is constructed on bottom slab. Actually, this roof form after construction of outer tank is finished. If concrete becomes hard enough, air pressure is injected into inside of outer tank. During construction of outer tank, roof of tank is built at same time. Roof is constructed on bottom slab. After construction of outer tank is finished, if concrete becomes hard enough, air pressure is injected into inside of outer tank. To lift roof up to top of outer tank. When roof is structurally integrated with outer tank at top. It says roof is constructed to bottom slab after construction of outer tank is finished. If concrete becomes hard enough, air pressure is injected into inside of outer tank to lift roof up to top of outer tank. Then we can say here, after construction of outer tank is finished, if concrete becomes hard enough, air pressure is injected inside of outer tank to lift roof top of the top of outer tank when roof is structurally integrated with outer tank at top. Wall in liner is installed on inside of outer tank. Wall Wall liner is installed inside when roof is structurally integrated with outer tank at top. Wall liner is installed on inside of outer tank, which serves as a vapor barrier of L and G. Most finally, once inner tank is constructed, construction of overall LNG storage tank is almost complete. Finally, once inner tank is constructed, what it says, when roof is structurally integrated with outer tank at top, wall liner is installed on inside of tank. Wall liner is installed on inside of outer tank, which serves as vapor barrier. Finally, once inner tank is constructed, construction of overall LNG storage tank is almost completed. Finally, once inner tank is constructed, construction overall LNG tank is almost complete. On the other hand, in construction method using PC panels proposed in this paper, after bottom slab is constructed, wall liner should be constructed to stand along with roof by using jack-up methods. Wall liner should be constructed with sufficient thickness to ensure structural stability when self-erection. Once wall liner should be constructed with sufficient thickness to ensure structural stability when self-erection. Once self-erection of wall liner along with roof is completed, outer tank and inner tank can be constructed at same time, which can shorten construction time considerably, you can say. In addition, since dismantling of temporary way out So wall liners should be constructed with sufficient thickness to ensure structural stability when self-erection. Once erection of wall liner along with roof is completed, outer tank and inner tank can be constructed at the same time, which can shorten construction time considerably. In addition, since dismantling of temporary form required in existing time considerably, shorten construction time considerably. In addition, since the dismantling of temporary temporary formwork is existing construction method is excluded, construction outer tank in this study, correction wall liner and PC panels can be used as permanent form for more economical construction. In proposed construction method, P and PC panel used as permanent form should be connected to each other. PC panels used in permanent form should be connected to each other using a sealant between adjacent panels and fabricated by inserting top shear connectors, fabricating by using internal loop shear connecting top surface that is a contact with fresh concrete to bond and with CIP concrete. So, and on surface that is contact fresh concrete to bond with CIP concrete. Also, since the wall liner has to withstand steel pressure, lateral pressure generated when concrete is poured. So 9 mm thicker than a conventional 5 mm thickness was used in accordance with design method standards. In process of concrete curing, wet curing is easier than the conventional curing. Wet concrete is easier. In process of concrete curing, wet curing is easier than conventional method curing PC panels. Methods curing of PC panels and wall liners used as permanent forms can block ambient temperature. Now there is a figure here which shows comparison between procedure of existing construction method and proposed construction method. PC panels and wall liners serve as permanent molds for pouring concrete as shown. Tie rod shows secret to a tie up. So we can say we have figure here which show difference of two proposed construction methods. PC panels and wall liners serve as permanent molds for pouring concrete. Tie rods shown in figure serve as tie-up wall liner and PC panels to prevent PC panels from falling during concrete casting. Now what is that? This is comparison of conventional and suggested method. Conventional method, suggested method, A and B. There is B. Let's say base slab. Let's start with this slab. base slab. Then there's the outer tank. You can see that outer tank. And if you see complete tank here, this is outer tank. This is your liner. This here is starting of cupola, and of course pressure is there. This goes up and reaches here. Here is liner only, not tank, and here is tank here. Now again shown base slab. This is for liner only, base slab, liner. This is the difference in two, and there's, now we take other one here. This is a walk table here, and this is precast concrete panel. Precast concrete panel. Here is wall liner inside. This is concrete panel. This is water table, and it is below that hangers. This is up to, this is not concrete yet. In order to verify constructability and structural safety of construction method, in order to verify constructability and structural safety of construction method proposed in this thesis, a full scale mock-up was constructed and tested considering PC panels and wall liner. Mock-up is designed based on LNG storage tank with a capacity of 200,000 kiloliter among ground operated full containment tanks. Considering the design strength and a PC panel is 40 MP. Mock-up which is applied to PC panels has a height of 10 meters, considering reasonable size for determining constructability and structural safety evaluation. And 12 PC panels were manufactured in total of 3 layers with 4 panels in each layer. Also, the height of one layer was designed to be 3.75 meters, which is same height as that of existing LNG storage tank. I feel cold now. Speaking is something. This was beginning temperature was so much, was 14 degrees now. It's come down by 1 degree till now, but here is 11 degrees dew point, so it is 13 is 14 and 11 degrees. We're talking of this tank here. This is, you can say, tank. Here is mock-up size, 12 panels, height is 10 meters, tank total height is 51.718, cupola free height is 10.463, and ring beam is 3.45. Real height of tank is 37.8 meters. If you see in this right side line work of this tank, this bottom slab, this PC panels size height of this is 10 meters. These all 12 panels shown 10 meters height. One is 1F, 2F and 3F. Then first height is 2.5 meters from slab. Second height is 3.75, third height is 3.75. PC panels width is 2.3 meters. Thickness of this wall is 750 mm, and of course there is 100 mm, 100 mm. You can say inside of tank line, wall liner. Inside there is 100 mm is panel, that is precast panels. 9 mm is liner. Concrete casting, you can see by that. So here is all this concrete casting. Here is wall liner thick, 9 mm thick. This is panel, you can say bottom slab. First, this is mock-up with PC panels. We have seen clear picture of this. These are other projects. Now, construction procedure mock-up with PC panel. Figure 7. Construction procedure mock-up with PC panels. As A, B, C, D, E, F. A is erection of wall liner. Erection of wall liner. B is assembling PC panel. Assembling PC panels. C is tie rod installation. D is concrete casting. E is concrete curing. And F is completed mock-up. You can see once again, A is erection of wall liner, has concrete panel fixing, or you can say assembling. Tie rod here, and here is concrete casting, and this is concrete curing. Top view from this. That's concrete curing and complete mock-up. Experiments for verification of constructability. To verify constructability and structural safety of proposed construction method through mock-up test, strain sensors were attached to second and third layers of wall liners. Strain sensors were attached to second and third layers of wall liner, which are most concerned during construction. Strain data of wall liner was collected while monitoring of strain centers. Section, you can start concrete casting. This is base, concrete casting here. Concrete casting, tie rods, this level casting, tie rod, casting point approximately, that is this one, and they are stain sensors 1 2 3 4 5 6 7 8 9 10 stain sensors in middle and at this tie rods, near tie rods. You may say locations are there, height is there, 110 meters height, and if you see in this elevation, top is 8.8770, it comes down, and there is a difference of 25. Start dimensioning here, 8770 and 8145, and this is 625. 625. Again there is 625, 625, 625, and the other one is, you can see, it's 2775. And if we are 625 to that one, it's different, I think. 2775 for difference is 00, 70, 870, 875. So it is also different one. Then 5.09, 4.395, 4.395, 5.0. So 605 into 20, 625. Likewise, that's this one, Well, now what it says. Now what are results? Let us see. Measurement experiment shown figure 10. This figure 10. Stress distribution of wall liner, second layer, third layer. If you see on horizontal x-axis, she says time. 1 2 3 4 5 6 7 time hours. That is MPa, stress MPa. That is minus 100 downwards and then 0, 50, 100 MPa. Time increases, this increases, stress increases. Stress MPa and time again. Conclusion. That's point. Now introduce a new construction method for LNG tanks using PC panels, and to discuss advantages of this technology to overcome limitations of existing construction methods. This new construction method using PC panels has advantage that an independent wall liner and PC panels can be used as In this new construction method, using PC panels has advantage that independent wall liner PC panels can be used permanently for construction of outer tank. Allow both inner and outer tanks to be constructed at the same time. In addition, mock-ups were manufactured in order to evaluate structural safety in construction steps. Experimental measurements were implemented. So we can say, in addition, mock-ups were manufactured in order to evaluate structural safety in construction steps, and experimental measurements were implemented by using stains and storage tanks. It's possible to shorten construction period since dismantling of temporary form is excluded in existing construction method. Because PC panels and well liners serves as permanent form, By applying precast concrete panels to LG tanks, it is it is possible to shorten construction period, since dismantling of temporary form is excluded in existing construction method. Because PC panels and wall liners serve as permanent form. PC panels and wall liners serve as permanent form. Continuity of reinforced rebar inside outer tank walls can be secured during during consider construction of outer tank. In proposed method, an additional process for self-erection. An additional process for self-erection of wall liner is necessary as a result of monitoring behavior of wall liner. In proposed method, an additional process for self-erection of wall liner is necessary as a result of monitoring behavior of wall liner through mock-off test. Structural safety is secured because it does not exceed allowable stress range. As wall liner becomes independent in construction of mock-up, it was as wall liner, mock-up test, structural safety is secured because it does not exceed allowable stress range. As wall liner becomes independent in construction of mock-up wall, it was required to carry out installation of reinforcement from one position, but found that there were no significant difficulties in reinforcing parts arrangements. Economically, additionally structural members RC panels are generated compared to conventional method, but construction costs are expected to be similar due to elimination of installation and dismantling of temporary forms used in existing construction methods. It says wall lines became independent in construction mock-up. It was required to carry out installation of reinforcement from one position, but there was no problem at all. Significant difficulties were found. Economically, additional structural members are generated compared to convenient method, but construction costs are expected to be similar due to elimination of installation of dismantling of temporary forms used in existing construction method. Since PC panels are lifted and installed with cranes during construction, safety countermeasures must be taken to prevent falling of PC panels. In conclusion, construction method of LNG tanks using PC panels can significantly reduce construction period and can be widely applied to various storage tanks regardless of capacity of storage tanks. However, it is desirable to carefully examine each construction step and apply it to actual construction of LNG storage tanks. This paper was supported by Education Research Integration through here is what we did. Is this paper which we can say satisfactorily we have gone through. We can just have a stress diagram again and see at different heights what stresses are here. Up to 120, 30, 40 MPa is stress and this is air. In time, that is hours between 3 and 6. and before that it's not much, it's considerable. This is actually total cycle here. Panels fixed. It's a hanger as well in this case, from working platform or table. And this old one, conventional one. So we can go back now, close it. Now we back onto our page. This is view of tank inside as well as outside. You can see here people are working efficiently. I'll go to another plate. Yes. Typical means not exactly same, but just indicatively I am showing. Indicatively, as I said, this is our hospital, and landscape wise it looks like that. And see that one. Just some of my projects. There are so many other projects which I cannot extract. We could not do that. Could not extract them from there because of various reasons. But here is what I'm trying to get you in. Whatever is possible, whatever is not possible, all that. As from every viewpoint, we have to think of how best we can extract from the, if it is at all possible, if it is at all possible, otherwise it's not something possible at all, you can say. Okay, I look into this and we will be back in a minutes, a couple of minutes, because this is a very important one. We can see. Yeah, I tried to find many more, but I could not find. I want to get school picture also. This is the beginning on this, that is first one. I'll try to get this one, but I could not do that, unfortunately. And you can see that. Let me come back in 5 minutes, okay? Hold on, please. Bear with me. It's like, temperature. I have to see again. I'm feeling cold. Yeah, I don't know why. Just a minute, please. Don't take it otherwise. It's just a everyday issue. Everyday issue, and it is 14 degrees now. So we can say, sorry gentlemen, little late, but this was my problem. You can see this hospital, I think model. It's actually located in Jeddah. Big project, but was difficult in sense of prosecution because of various reasons, not one reason. Unfortunately, this was never controlled by professionals. It's multinational project, various engineers from various countries. I think I was only an engineer for short while here, just for a couple of months, 6 months, but Egyptian engineers, many more engineers from Philippines, and from many other countries collaborated together, and fate of this project to an extent construction was concerned has gone into ashtray. No controls of quality, no controls of progress. Hodgepodge, complete hodgepodge. Pakistani consultant had and many Indians there, as well as this was owned by Ministry of KSA. I did not see such lack of control anywhere involved. Is included there. It's just an example. As you 2010, not very becoming, many shortcomings in progress and quality, etc., etc. I can say they don't work well. I don't want to criticize someone, but I'm just giving my experience to you, which is of course very important from every viewpoint. We should be frank and true to work, and that's very important one. We can say, let's see now, as far as we can say coordination engineering is concerned, coordination engineering is friend of none. It has to be done in fact. It has to be done in fact. Without doing this, nothing can move. Therefore I say coordination engineering, and in fact missing coordination means missing good engineering. This we have to understand. If you don't coordinate, you cannot do good engineering. It's not only in civil, it applies to every branch of engineering, and in fact to every branch of work, whatever we do. Communication support for reliable coordination is very important. I wanted to get actual photograph of this from internet, but I could not find. This is from Google. This was taken from Google. I tried to get photo, but I could not trace that. Maybe it's due to some reasons. But this, when quality was better than quality today, in those days when there was no facilities, and this was my first good project in career, I can say. Good in a sense that I did better projects than this also, but in Gulf, an open way where I did one project in Libya also. I don't have photograph of that. Due to that time, there was a photographic system. That's why I say communication support, reliable coordination. We have these days very good communication system, but do we communicate? That is a question mark. Do we communicate? And I can answer, we can communicate in abusive way, not in usive way. It is abuse of communication. It is not really used to corroborate coordination, corroborate system, but just to abuse that, and which is not good at all. I can say not good at all. Sometimes simplicity pays, sometimes it does not pay. Complexity does not pay. Sometimes simplicity works. So you can see design from top of this complex of building, which is a school, and so simple in design, but it looks nice. No hodgepodge, and whatever hodgepodge is there in fascia, that is intermediate, that is down in assembly hall only, and maybe somewhere else, but ultimately it's good design. You can see, again I tell you, this is building of assembly hall and its support, and this is corridor of assembly hall, open corridor, and here is air handling units. In this is chiller units, Kaplan workshop, and of course these are stairs and other areas. You can see stairs and other areas where there is a stair cover here, also something here like that, and this is a classroom toilet here. You can see these tanks, etc. And this is classrooms, all this also likewise, and here all rooms, lecture rooms, laboratories, and this is official area. This is podium, is open to sky, though it's covered by this you can say something like polycarbon shed, and this is a pergola, and here is a mosque, and there is a substation here. You can see that one. There's the gatehouse, guard house. You can see this substation. Here are some, you can see some facilities like septic below. All this all at that time this route was main road. Now it's further developed. That's beauty of that one. We can say you have to understand these points clearly, and it's very important. It's a very important chapter for us to know value of coordination. I was too young here in 1986. I was, I think, 31 years. I was not very good in handling others. For example, consultants. So I was working for contractor, which requires extreme knowledge. But I also looked at others who didn't have anything in their minds. Lebanese engineers particularly, British engineers, and of course many other nationalities of lower class like Thailand, Havars, Pakistanis, Bangladeshis, Sri Lankans, many more. I always say that in my career I worked with more than 50 nationalities, and that's my good luck, I can say. It's not a question of money, a question of exposure one has got. I know I could understand what was the intention behind these people, what culture they come from, and how they conduct. In openness is required. Openness and not bureaucracy. And access to your office is required by everyone, whatever time, during work hours. And for your work, you have to decide different time where you are separate. You can concentrate on your mind. But during work, you have to help yourself by helping others. There's no official body, there's no hierarchy, there's no system. Only way is how do you react with people. It's your duty not to waste time of those who come to you, to attend them in sequence at an earliest. Wasting time of others means it's your own wasting time. Your own time you waste. Though it's very small project if you compare today, but that time it was considerable project to an extent job market was concerned. At that time in 1987, 86, it was 14 million QR, that's Qatari Riyal, and that was considerable sum for civil contractors project because of having very little chances for project in those days. Economy was down, but this was good project. 1.5 years minimum, 18 months, and I was fortunate to take over this site from government. I was fortunate enough to start its original work, and I could complete its structure, many of its finishes, except certain, final decoration because I had to come on vacation, and that time I came on vacation, and some architect took over for decoration items. Then I had to deal with other project that had to come in. So I could not hand over this, that was different, but most works carried out. There were many problems were exposed on this, structural problems, or shuttering opening problems, certain slump problem, concrete slump, and some other backfill problems due to whatever reasons these were. We resolved and I designed my own format for progress report and for many other issues, and I still use them. Means I do not write unrequired, surplus or redundant information, no use. We should be tactical one. You should have some sense of what is required and what's not required. Long formats no use if these don't have weight. If you don't have weight, what's the purpose of that format? I can't understand. Weightless format has got no meaning. One should have sense of doing the task. Of course, I had some problem with some young consultants there, but I was consultant for them. In fact, I got my company, my organization, contracting used to call me not a contracting person, and I also lost 1 month's salary due to that, because when time of bonus came, my bonus should have been at least 2 months, though it was issued a month, but I could not deliver project in exact time. So say you are not a contracting personnel, you are not a contractor. That alias Francis, one engineer, he was head of our section, our division, and he used me a lot indeed. There's no doubt. He exploited me as far as work is concerned. I am happy for that. But at end, he said that you are a consultant, you are not a contractor. I won't pay you 1 month bonus. I pay only 1 month. I said keep this also, no problem. But he was impressed many times, and I was also happy that he used to ask others, my colleague, another one, Engineer Rajiv Gakar, one TV Thomas, quantity engineer. He sought advice from them. What is this person about me? From where did he qualify? And those people did not give right answer, unfortunately. But he said that I want to get such engineers for my company. How can I get them? Well, I don't know what they said about that, but they, of course, passed some adverse comments, which I did not like. Well, I won't say what that was regarding Section A and Section B of II. But this should not happen that way, It's performance that is important. It's not important from where do you qualify. Even if you qualify best university, and you don't perform, there's no relation at all. Even if you're a doctorate and you don't know what to do. I was not a contractor. I never did contracting in my life. I started as a supervisor and a controller or engineer, what I can say, a consultant. I am good in investigation, I'm good in checking of works. But if you can do yourself, you're a contractor simply. How to do yourself, but cost is important. Everybody wants to make profit. And if you strictly check, you cannot allow much profit, and that's only a problem. Well, it's a different case. I would like to say that. I still believe that profit would come, but you cannot get profit by deception. You cannot get profit by, you can say, cheating. You cannot get. I'm leaving now at this moment this talk. I'll try to search more information if I can get, otherwise I will continue with our coordination talk as usual. It's good one. I take your leave now, and thank you very much, I would say.